Welcome to our module on absolute value. Absolute value refers to the distance of a number from zero on a number line, regardless of direction. In other words, it measures how far a number is from zero. It is always non-negative, which means it is either positive or zero. As we look on this number line, we see there are two numbers that have a distance of 4 from zero. The number 4 is 4 units away from zero, and the number -4 is also 4 units away from zero. The absolute value of a number is represented by these vertical bars. This is read as the absolute value of x. For example, the absolute value of 5 is 5, and the absolute value of -5 is also 5, because both 5 and -5 are 5 units away from zero, as demonstrated on this number line. The absolute value of any positive number is the number. As we see here, the absolute value of 5 is 5. The absolute value of any negative number is its opposite. As we see here, the absolute value of -5 is also 5. The absolute value of 0 is 0, as it is exactly at 0 on the number line. The absolute value of 0 is 0. Notice that the absolute value of -5 equals the absolute value of 5, as they both equal 5. This is because there will always be 2 points on a number line that are 5 units from the origin, one on the left and one on the right. That means that given the equation absolute value of x is equal to 5, there would be two solutions, 5 and -5. The center of the absolute value, in this case 0, is also the midpoint of the two solutions, since the origin is centrally located between the two solutions, -5 and 5. Let us now turn our attention to absolute value and opposites. The solutions to the absolute value equation, the absolute value of x equal to d, were opposites. This idea is captured in this statement. The absolute value of opposites are equal. Two expressions are opposites if their sum is 0. It follows that a and b are opposites if and only if a plus b is equal to 0. If the absolute values are opposites, let us determine whether these statements are true or false. Take a moment and determine if these 5 statements are true or false. Is the absolute value of -5 equal to the absolute value of 5? Is the absolute value of 3x equal to the absolute value of -3x? Is the absolute value of x minus 7 equal to the absolute value of 7 minus x? Is the absolute value of 12 minus x equal to the absolute value of 12 plus x? And finally, is the absolute value of -9 minus 2x equal to the absolute value of 2x plus 9? Take a moment and consider these before advancing the video to see what the answers are. Now that you've taken a moment to consider your answer to these 5 questions, let's examine the answers. The first 3 are all true because the expressions are opposites. -5 and 5 are opposites, so therefore the absolute values are equal. That is a true statement. 3x and -3x are opposites, therefore their absolute values are equal. That is a true statement. This may be a little trickier to observe, but x minus 7 and 7 minus x are opposites because if I factor out a negative, 7 minus x is equal to the opposite of x minus 7. So this is a true statement. Next, we have the last 2 problems. Now, 12 minus x and the absolute value of 12 plus x are false statements because 12 minus x and 12 plus x are not opposites. Therefore, the absolute values are not equal. But -9 minus 2x, that absolute value is equal to the absolute value of 2x plus 9. That is a true statement. And here's why. If I factor out a negative, I have -9 minus 2x is equal to the opposite, factoring out a negative, of 2x plus 9, which is the opposite. Therefore, the absolute value of opposites are equal. That is a true statement. Now we're going to talk about what we refer to as the basics. The basics refer to absolute value rules which are always true for any real number. So the following expressions are also always true for absolute values. Now the middle expression uses the number 2, but you can use any number. Any real number will work instead of 2. And I can pick any real number I want for the values of a and b. So for a, let's let a equal 7, and b, I'll let that be negative 13. So for the first one, we have the absolute value of a times b is equal to the absolute value of a times the absolute value of b. So if I plug in my numbers, I'm going to have the absolute value of 7 times the times negative 13. 7 times negative 13 is negative 91, and the absolute value of negative 91 is a positive 91. Now let's check it out with this half here. I can take the absolute value of 7 times the absolute value of negative 13. Now the absolute value of 7 is 7. The absolute value of negative 13 is positive 13. 7 times 13 is 91, and we see in both cases we get a positive 91, so it checks out. Next, we're going to try 2 times b, take the absolute value, and see if that's equal to 2 times the absolute value of b. So let's take 2 times negative 13, take the absolute value. Well, 2 times negative 13 is negative 26, and the absolute value, negative 26, is positive 26. Now we'll consider the second half. 2 times the absolute value of negative 13. Well, the absolute value of negative 13 is positive 13, and 2 times positive 13 is also positive 26. They are also true, so that checks. Let's consider our last example. The absolute value of a minus b is equal to the absolute value of b minus a. So let's take a is 7 minus negative 13. So 7 minus negative 13 is a positive 20. And the absolute value of positive 20 is positive 20. Now let's reverse that. Let's take the absolute value of negative 13 minus 7. Well, negative 13 minus 7 is a negative 20. And the absolute value of negative 20 is positive 20. And that too is equal. They're both equal to positive 20. So that also checks. So these rules right here are true for any real number. And by the way, this middle rule is true for any number besides 2. You can pick any real number besides 2, and this will work as well. Now that we have covered the basic properties which are true for all real numbers, let's take a look at 5 examples and determine whether or not these 5 examples are true or false. This would be a good time for you to pause the video, consider each of these 5 examples, and determine which one is true or false. After you made that determination, start the video and I will reveal the answers. Now that you've had a chance to consider whether or not these are true or false, these are what the answers are. And you'll notice that all of them are true except for this third one. The first one is true using this second property right here. Okay, that's why that's true. What we did was we replaced 2 with 5 and we replaced b with a, but the property is still the same. The second one is true using the first property. What I did was I replaced a with x and b with y, but we see this is true. The absolute value of x times y is equal to the absolute value of x times the absolute value of y. You can try these with any real number that you want. This next one is interesting. This is not true, it's false, and that's because only constants can be taken out of the absolute value, not variables. Let me illustrate this. Let's say that x is equal to negative 1 and that y is equal to 3. So for this first one, if I take the absolute value of negative 1 times 3, that's going to equal the absolute value of negative 3, which is positive 3. Now, if I take, I'm going to write down here on the bottom because I'm out of room, I'm going to take this expression and rewrite it down here. So x is negative 1 times the absolute value of 3. And the absolute value of 3 is positive 3, so I have negative 1 times 3, and negative 1 times 3 is negative 3. These are not the same. 3 is not equal to negative 3. So this is a false expression. The other two are also true. This is true because we're using the second property. And the second property here is I factored out a 2, and b is represented in this case by an algebraic term, 6 minus x. So if I take 12 divided by 2, that gives me 6. 2x divided by 2 leaves me with just x. And I take the absolute value of 2, that leaves me positive 2. So the absolute value of 12 minus 2x is equal to 2 times the absolute value of 6 minus x. This last one is true because we're using the second and third property together. Let's analyze this one more in depth. That last example was more complex. You can use more than one property of absolute values, reduce and simplify more complex expressions. So if we start with the absolute value of negative 9 minus 3x, the next thing I would do is factor out a negative 3. So I factor out my negative 3. That leaves me negative 9 divided by negative 3 is a positive 3. And negative 3x divided by negative 3 is a positive x. Next, I take the absolute value of each product. So I take the absolute value of negative 3 times the absolute value of this algebraic expression, 3 plus x. The absolute value of negative 3 is positive 3. And it says here, we simplify, so the absolute value of negative 3 is equal to 3. And finally, we know that 3 plus x is the same thing as x plus 3. So we were able to establish that this algebraic expression is equal to this algebraic expression. To emphasize this point a little bit more, I'm going to pick another example that wasn't in the original set. Let's consider the absolute value of negative 12 minus 6x. So we start with the expression and we factor out a negative 6. Next, we use the absolute value of a times b is equal to the absolute value of a times the absolute value of b property. And I take the absolute value of each of my two products. Next, I simplify. The absolute value of negative 6 is positive 6 right here. And we know that x plus 2 is the same as 2 plus x. So I rearrange these two by using the commutative property. And we've established that 6 times the absolute value of x plus 2 is the same thing as the absolute value of negative 12 minus 6x.